join me, given the party last night. Today I'm going to tell you a story, but first I have a question for you. Do you have a side gig? You know, something that brings in a little extra each month. I do. By day, I'm a product manager for a software team in a bank. But by night, I'm a private investigator. And what is it I investigate? Ruby crimes. Not jewel theft, the programming language. And why did I decide to go into private investigating? Well, there's been rumors of a shady mastermind causing havoc and confusion amongst Ruby developers worldwide with his constant meddling in the source code. And I wanted to help put a stop to it. But I couldn't do this under my real name. I needed to protect my identity. And so I chose Deirdre Bug, D for short. And why did I choose this name? Well, for the sole purpose of making this joke. And today I want to tell you about one of my more memorable cases, the case of the missing method. Chapter 1. So I'm sitting alone, bored in my office, my flat, when the doorbell rings, and it was Mike, and he didn't look too happy. Let me tell you a bit more about Mike. So he was an acquaintance of mine. We had some mutual friends. We saw each other now and again. He was 24 years old, a junior Ruby developer, and he got excited about test-driven development. And he'd been applying for an apprenticeship at the prestigious Ruby Institute of Professionals. And he managed to get through all of the stages, beating hundreds of applicants to the final stage. And this was happening in 2 days. And there were 2 people left fighting for the last spot, himself and a woman named Jenny. So Jenny was 27 years old. She was also a junior Ruby developer, and she loved all things Rails. She also was Mike's best friend and housemate. So they had quit their consulting jobs together to enter the world of tech, and not long after, they also decided to live together. And so for the interview, they'd agreed to work together to prepare so that each of them had the best shot. May the best person win, they'd said. So they'd been asked to research a series of topics that they were going to be grilled on in the final stage. And one of them was method lookup, and this had been assigned to Jenny. And here was the reason that Mike had come to me. Something doesn't add up in Jenny's notes, he said. So Jenny's been so stressed and panicked, though, rather uncharacteristically, that she won't hear me out, he continued. And she's convinced that she's right and that they don't have time for Mike's doubts. And he says that if I can help him find the answer to this mystery, then he'll have what he needs to confidently correct Jenny and save them both from interview failure. So he reaches into this satchel and he draws out some sheets of paper, and they're Jenny's supposedly flawed notes. And I ask him to walk me through them. So Jenny had these boxes to represent the concept of a Ruby object. And all of the objects had a label called class. And this acted as a reference to the parent class of the object in question. So some objects are instance objects. And the class label for them refers to another Ruby object of type class. All objects of type class also had their own class label. And they also had something called a methods label. And this pointed to a table of all the methods that instances of that class could call. And then there were some handwritten notes beside the diagram that said, any class that you define is an instance of a class object called class. So if we were to write class cake in our code, we're creating a class object named cake, and it's an instance of another class object which has the name class. So all classes are of type class with a capital C. And then she had this code in her notes. So we had class cake, and we had 2 methods. An instance method called tasty, which returned true if the flavor of the instance was carrot, and that made sense to me. And then we had a class method called edible, which always returned true. And then she wrote, imagine we had a cake instance called carrot. So carrot equals cake.new. And then she said, this is what the method lookup chain would look like. And so this was the diagram that I saw. She had one of her orange boxes labeled carrot. It had a class label. That pointed to another orange box labeled cake. It also had a class label. It also had a methods label that pointed to a table which had the entry tasty. And then the class label here pointed to another box labeled class with a capital C, and that had its own methods label pointing to a table with the entry edible. And then she'd written beside the diagram, a method definition always comes from an object's class. And at this point, Mike shook his head in frustration. And he said, it cannot be that the edible method lives on the parent class for all classes. He asks if he can show me something and if he can jump on my computer. So I agree. He goes over to my desk, opens up a terminal, gets into Pry, and loads in the cake class from Jenny's notes. So the first thing he does is shows me that the class of cake is indeed class. And then he searches for the edible method in all of the instance methods for class. And it wasn't there. What a mystery. And I'm stumped. I'm really not sure how to proceed with this one. But I think that if anyone can do it, Debug can do it, because she loves a challenge. And besides, this meant a lot to Mike. He was prepared to pay me handsomely. And so I agreed to take on the case. Chapter 2. Ever heard of Google? Maybe if you care more about privacy, you're all about DuckDuckGo. Well, when I'm D, I don't believe in these tools. I don't trust them. And it's no coincidence that with this approach, I've become the best Ruby PI that the industry has to offer. But without search engine tools, what did I have? Books. Books, books, and more books. And I spent a whole day quickly skimming a load of books, but I couldn't find anything useful. So I decided to form a hypothesis and go from there. So I said, well, the edible method, while not in cake, must be somewhere in the ancestry tree. What's the ancestry tree? Well, it shows all of the classes and modules that a class inherits from. So all the possible places that a method could come from. And then I created this where method. And it took 2 parameters, an object and a method. And this would help me search the tree. So it looked through all of an object's classes and ancestors, trying to find a class where the instance methods of that class, and only that class, included the method we were looking for. So I thought, let me check it's working. I created an instance of cake and checked that I could find tasty on the cake class. And now it was time for the moment of truth. The edible method must be somewhere. But it was nowhere. Nowhere at all. What a mystery. And so at this point, I'm confused. So I thought, let me take some fresh air. Let me have a change of scenery. So I decided to head to my favorite co-working space. And here I feel at home. I'm surrounded by people hacking away. And I quietly settle down at one desk. But given my naturally inquisitive nature, my eyes couldn't help but stray to the screen of the guy next to me. And I saw that he was messing around in IRB with something called object space. So I said, what's that? Because it looked interesting. And he said, well, it's a way that you can interact with all of the live objects within a Ruby session. For example, here's how you can count all of the live class objects that you have in a Ruby session. So I thought maybe it was time I should take a break, and I decided to have a little play by myself. So I went into IRB, and I counted all the class objects that were in the session I just started. So I thought, 936, let me create a class and see that that number goes up by 1. 938, that was strange. I thought, maybe I'm seeing things, let me try again. 940? What a mystery. 2 objects? But I couldn't spend too long thinking about this because just then the phone rang, and it was my friend wondering where I was. I'd completely forgotten that I was meant to go to a tech lecture with her. And I was anxious that I didn't have much time to complete the case for Mike, but I'd also been canceling a lot on this friend lately, putting my PI duties first. So I thought that on this occasion, I should make a bit of time for her, and I rushed out of the door. Chapter 3. So I remember that I turned up just in time for the start of the lecture. And it was about a language called Smalltalk. I wasn't interested in it at all. I only cared about Ruby. But I was there for my friend. And I remember that the lecture said that Smalltalk had been created in 1970 and that it had led to the birth of object-oriented programming. But I couldn't concentrate for much longer. I couldn't stop thinking about my play with object space. Each time I'd created one class, but yet 2 new objects were created in the session. Psst, pay attention, my friend said, nudging me. So I did. And I looked up to see the lecturer asking, what is the class of a class in Smalltalk? And she had this code on the screen, and I hadn't quite been paying attention, but I could see that she'd printed out this polygon object, and then she'd asked what was the class of the polygon object, and that had returned polygon class. And then she asked the system what was the class of the polygon class, and that had returned a meta class. And then she said the class of a class in Smalltalk is called a meta class. And she went on to say that, in fact, all of the languages that had been inspired by Smalltalk had their own concept of metaclasses. And that included Objective-C, Java, Python, and Ruby. Something clicked. 1 class, 2 objects. So I made my apologies to my soon-to-be no-longer friend, and I rushed out of the door and ran home. I thought I'd try my luck. But of course, that would be too easy. And so I thought, let me see all the methods that exist on the K class. I found that pretty overwhelming, so I decided to filter it down to all of the methods that included the word class. And so this was much better, and 2 of these stood out for me. One of them was superclass, and the other one was Singleton class. So the first thing I thought was, let me remind myself of the ancestry tree for cake. And I knew that these were all of the objects where edible wasn't hiding. And then I said, let's see what superclass returns. So I immediately knew it wasn't the answer, because object was already in the ancestry tree that I'd already searched, so it was just providing me with a subset. So I thought, let me try Singleton class. Ooh, this was something I hadn't seen before. And when I checked the ancestry tree, there were a few new things that I hadn't seen before. So at this point, I was excited. And I went back to my where method, and I changed it so that instead of looking at the ancestors of an object's class, we looked at the ancestors of an object's singleton class. So that way, I could search the 3 new things that I'd found. And then it was the moment of truth. Result. And I thought, let me just quickly double check what's happening. And in my excitement, I forgot how to type momentarily. But I got there eventually. And I confirmed that the edible method was hiding on Cake's singleton class. Case closed. Chapter 4. So at this point, I'm delighted, and I'm super excited to share the news with Mike. And I also took a moment to wonder whether I should retire, because this would prove to be one of the biggest successes of my career. And they also always say that you should quit while you're ahead. But anyway, I picked up the phone, gave Mike a call. The phone rang for what seemed like forever, and I was worried that I would never reach him. But finally he answered, and I said, I've solved the case, can I come round? And he was excited. He said, of course, come round, I'll have the notes ready and waiting for you. But although the case was solved for Mike, I still wasn't satisfied. I just discovered a whole new concept in the language that I hadn't heard of before. What are singleton classes? So instead of going directly to Mike's, I decided to take a detour to visit a friend of mine. Her name was Ellen. She was 43, a freelance developer, and she regularly contributed to the Ruby code base. I proceeded to tell Ellen all about the case. And when I'm done, I ask her, so what are these singleton classes all about? And she says, well, they're hidden classes created internally behind the scenes in Ruby. And they're there to hold methods defined only for one particular object. So take your instance carrot of the cake class. Its Singleton class would hold methods specific to carrot only, and not to any other instance. Say if you had one called chocolate or red velvet. And I said, okay, well, given that they're working away behind the scenes, when does knowing about them become useful? Ellen thought for a while, and then she told me about one of her recent clients. They were called Budgeting Inc., and they were a clever artificial intelligence, machine learning, personal finance tool for small business owners. And they were expanding globally, and they needed to roll out slightly unique versions of their software for each new city that they entered. So Ellen told me how when she first looked at the code base, she was horrified, because different developers had been responsible for each new city. And it looked like they were trying a new approach for each thing, whether that was naming things, testing things. And so there was a lot of duplication. And sometimes it was obvious where things were repeated, and sometimes it wasn't. But this meant that there was lots of wasted time on development because people were reinventing the wheel and often doing a bad job. And so there were lots of bugs. Some things were hastily copied, some things were left out, and it was difficult to see what was important. And so the developers were unhappy because they had a lot of tiresome work, the cognitive load was high. And the product owner was also unhappy because delivery was either slow or things were spun out very quickly and were bug-ridden. So Ellen wasn't quite sure what to do, and then she said she decided to create a DSL, a domain-specific language. And she asked me if I knew what she was talking about. It's a mystery to me, Ellen, I said. You'll have to explain. So she said, she beckoned me over to her computer and she said, let me show you a basic version of a DSL. So she opened up a pry session and input this class. So it was called city instance. It had a class method called construct, which took a block. It set up a city variable, which called to initialize via the new keyword. And then we called a method called instance eval on city and passed in the block that we'd passed into the method. And Ellen said I should pay attention to this line because it would prove to be important later. And then we returned city. Then we set an attribute reader up called taxes. We had the initialize method, which set up a taxes collection instance variable as an empty array. We had a method called tax, which took a name, and that pushed the tax onto the taxes collection. So now it's time to give it a go. So she created a city called New York and added some taxes. And then she printed the taxes out. And there we have it, Ellen said, a very simple DSL. And we can quickly spin up these lightweight city objects. And then she said, well, imagine if we had other properties like lists of banks and finance schemes. Or imagine if we had a bit more information about each of the properties. So we've only used the name of a tax, but what if we had other information about rates or thresholds? Well, using this simple starting point, it wouldn't be hard to extend the city instance class to create incrementally more complex city objects. Well, imagine taking that to the next level, Ellen said. She said, imagine interacting with the same city instance class in the same way on the command line. But instead of just creating variables in a pry session, we're spinning up new subclasses of city and other related models like tax, scheme, banks. And so she explains to me that this was the sort of thing that she had produced for Budgeting Inc., a DSL that had allowed for quick and easy scaffolding of each new city and the related subclasses. So now we know how to spin up identical city instances with different names and different taxes. But what about if one city had a quirk? So she asked me to think of a place in the UK, because that's where I'm from. And so I suggested Bath, because that had been the scene of my last investigation. And so she set up Bath and added a tax. And then she asked me to think about something that made people in the UK unhappy. But she didn't like my suggestion. She thought it was a bit controversial. So she went for the fact that it rained all the time. And she said that when it does, the government calls an amnesty and gets rid of everyone's taxes. So we printed out Bath's taxes, and then it rained, and so the government called an amnesty. And all the taxes were gone. And she said, remember our friends in New York? So they've heard about this rainy day amnesty, and they want one too. So the next time it rains, they call one. But it doesn't work. Undefined method, rainy day amnesty, for city instance, and then there were a load of letters and numbers. And Ellen said, well, let me show you what that is. And she called Singleton class on New York. And she showed that they were the same thing. So she said that when we enter the realm of DSLs and we start calling methods like instance eval, we're leveraging the existence of Singleton classes. Because what instance eval does is it stores any method declarations passed in via the block on the relevant object's Singleton class. But she said, hold on to that thought, we'll come back to it, but let's take a step back to the high level. So by creating a DSL like this, it enabled the developers to spin up each new instance of a city effortlessly. So she explains how she had now managed to abstract out all of the key similarities between any city, and that the developers had a frictionless way via the command line of spinning up the foundation that they needed. And the whole code base was better maintained because all of that scaffolding had been well tested. Ellen had done that once, and none of the other developers had to worry about it now. They could now focus on the interesting bits, which was the customization required for each new city. So the scope was much more refined. So now the developers were happy because interacting with the system was so much better, and it was much easier to have a high-level overview of the whole domain in their head just by reading the documentation of the DSL. And the product owner was delighted also because there were far fewer bugs, delivery was faster, and she could also speak in the same language that the developers were using by expressing new requirements in the terminology of the DSL. But let's go back to Singleton classes, Ellen said. So why is knowing about them useful? Well, she says that one of the main reasons that she was able to complete the project to a high standard was because she always understood exactly where she was defining methods at any given time. Because once you start entering the realm of dynamically creating classes and methods on singletons, the class hierarchy and method lookups gets far more interesting. And you'll be getting error messages like the undefined method one we just saw, and you need to be able to spot where singleton methods and classes are involved and where they're hiding, because it can save you from a lot of headache. So then Ellen turned to me and she said, well, do you know what the class of a singleton class is? And I said, yet another mystery, Ellen. And so she told me to go and investigate that as homework. I still haven't got around to it yet. Maybe one of you could help me later. Anyway. Ellen said, but beware, I've been going on about DSLs, but they're not the answer to everything. So if you have complex repeated business rules and you need to customize behavior in some certain cases, then consider DSLs as an option. But even then, approach them with caution. But, Ellen said, you don't even need to be writing them for it to be beneficial for you to understand the basics of how they work. For example, if you're using Rails, you're seeing DSLs every single day. And she went to the Rails Guides website and showed me that active record migrations were carried out via a DSL. So that's what happens when we write create table, t.string, and specify the format of our columns. And when we specify how our Rails app handles HTTP requests, that's also done via a DSL. And it occurred to me that I'd always just been doing this stuff by rote, and I hadn't stopped to think about what was happening behind the scenes every time I typed the resources keyword into my roots.rb file. And there's more of these, Ellen said. And she said that when people talk about Rails magic, it's not really magic. It's just a collection of well-written DSLs. And then Ellen said to me, I hope you're TDDing all of the time. And I said, of course. What do you take me for? And she said, well, our spec, with its describe, context, and it blocks, are all DSLs as well. And so with all of these Rails and RSpec DSLs, knowing about singleton classes can help. Because you might find yourself in a tricky problem and you can't make head or tail of it, particularly if you inherit a code base from somebody else. And she said, if you're seeing a funny bug to do with methods, you never know. Singleton classes might be involved. And so if you have them as part of your suite of debugging tools, it can be very useful. And so I was feeling really leveled up by the end of this conversation. And so armed with this new knowledge, I headed over to Mike's house. But when I arrived, I found a Mike who had tears in his eyes. He'd obviously been recently crying. and he had crumpled pieces of paper in his hand. And he raised his arm towards me, offering me the papers. And I looked at them, and they seemed exactly the same as the method lookup notes of Jenny's that he had brought me the day before. So I couldn't see what was wrong. We had the carrot box labeled with carrot, and that had the class label, which pointed to another Ruby object called cake. It had its class label, and it also had its methods label with the tasty entry. And then we had the class box with its method label pointing to edible. But wait, it didn't say class this time. It said cake Singleton. And as Mike saw me notice this difference, he fell to his knees and broke down in tears. Jenny knew about Singleton classes all along, he cried. He'd gone into her room to find the notes in advance of me coming, and this was the copy that he'd found. Jenny was so desperate to secure the job for herself that she set out to intentionally mislead Mike in the hope that he would fail a whole section of the interview and therefore look underprepared. I, for one, was disappointed in myself because I'd been so focused on the main villain, the shady mastermind, that I'd failed to spot a villain right under my nose. My best friend tried to sabotage me. And at this point, Mike started wailing again, saying he wasn't going to go to the RIP interview. And I said, nonsense, you can't give up now. I sat down next to him, I gave him a comforting pat, and I said, you can do this. And I have just the thing to set you apart from Jenny. So he looked up hopeful. Have you heard of DSLs? I asked him. And I proceeded to tell him everything that Ellen had just shared with me. And although Mike still looked devastated as I left him, I had confidence that I had inspired him with the knowledge and power of Singleton classes, that he'd pull himself together and go and secure the RIP internship for himself. So it's 2 months later, and I managed to drag myself to a Ruby hack night. And when I arrive, I'm milling about, enjoying the free food and drink, when I hear a couple of people whispering in the corner. Ooh, she's Ruby famous, one of them says. And I look across the room, and who do I see? Ellen. So I walk over, we catch up, and I tell her I've been reflecting on the case of the missing method and my takeaways. So Singleton classes are there to hold methods defined for a particular object. And that when you understand them, it opens up a whole new world of Ruby, dynamically creating classes and methods on the fly in more complex applications using things like DSLs. But I said, I still feel like I can get by day to day ignoring them. So do I really have to care about them? I asked her. Not really, Ellen said. Like you say, if you are writing DSLs, then definitely do know what you're doing. And they do underpin popular frameworks like Rails, but day to day you can get by. However, she said, understanding why singletons are there, I think, is super interesting and empowering. So think of the Ruby core team. They wanted to keep things as straightforward and simple as possible. And by simple, she said they wanted to minimize special cases, so aim for having one way, one pattern for explaining how anything worked. How consistent can we get things is something that they continually asked. And so if we think about consistency and apply that to the realm of Ruby methods, well, all methods in Ruby are defined in only one of two places, a normal class object or a singleton class. And really, every method in Ruby is an instance method. A method lookup always starts with a singleton class. And class methods don't really have any fundamentally different behavior to other methods. What we call class methods are really instance methods where the object in question is a class and the method is stored on the class's singleton. So yeah, singleton classes are invisible, she said, but they're everywhere. They're a fundamental part to how Ruby and its method lookup works. So I left the hack night deep in thought. Ellen had inspired me to explore more of Ruby behind the scenes because there was so much that I didn't know, and I had only scratched the surface. And I'd always been a general Ruby PI, and had been very successful. But I thought perhaps it was time to find a niche and reach the next level.
Okay, hi everyone. It's time now for the pitch of the next location. So we have 3 contestants. I'm doing that because Flor will also be pitching and, you know, conflict of interest. Yeah, so maybe everyone who submitted a pitch can like start sitting in the front of the... So we'll start first come, first served. So Miles for Bristol, England. All right.